Alright, now that we have all the values, so we state all the values together, which is from state 1 until state 6. And we recall back what are the questions try to look for, which is the first one is the work of your turbine, and the second one is your thermal efficiency. And because this is about your reheat Rankine, so you know that you are going to have two types of turbine, which is one your high pressure turbine and the other one is your low pressure turbine. So if you have a look at this DS diagram, you will see that your high pressure turbine is in between state 3 and 4, and your low pressure turbine is in between states 5 and 6. Therefore, in order to solve for your total work of your turbine or total work output, so you are going to minus H3 with your H4 and sum up with your H5 minus your H6. So finally you will get for your A, which is total work of your turbine, is equal to 1366.41, and the unit is in kilojoule per kg. If the question asks you to find the final answers in kilojoule, then you need to find your mass. But since in this question you can leave it in just kilojoule per kilogram, or the work turbine per unit mass. So next we are going to solve for your thermal cycle efficiency, where you have two ways. One is by using this equation, another one is by using this equation. So if you are going to use this one, so your work net here is the total of your work turbine minus with your work pump, which is in between state 2 and 1. If you are going to consider this equation, you will need to find for your Q out, which is it's happening in the condenser over here. So you are going to minus your H6 with H1. And your Q in, you have two times, which is the first one during your boiler, and then going out from your high pressure turbine, your water or your steam is undergoing the second reheat over here. So when you're considering your Q in, you will sum up from state 3 minus with your state 2 and state 5 minus your state 4. So let's have a look at finding your Q in. So for B, your Q in is equal to your H3 minus your H2 plus with your H5 minus your H4, and you will get 3492.06 kilojoule per kg. Alright, so for your work net, it's actually summation of your work turbine minus with your work pump, where this value of your work pump is the one that you already obtained in your state 2. If we want to write back your work pump, it's actually where you got from state 2, where you times your V1 with P2 minus your P1. Therefore, you make use of this summation of work turbine that you got over here, and you minus with the work pump that you got in state 2. Finally, your work net will be equal to 1358.29 kilojoule per kilogram. So substitute the value that you obtain for your Q in and your work net inside this equation. So you will get your thermal efficiency is equal to 1358.29 divided by 3492.06 times with 100. So finally you will get 38.89% of thermal cycle efficiency. So this is proof that you are looking for. Alright, I hope that this video will help you in solving for your ideal reheat Rankine, and please try on your own to find thermal efficiency using this equation. Thank you.